Good morning, good afternoon, good evening. Welcome to my session of Live Coding 12-Factor App. I am Emily Jiang from IBM. I'm the Liberty Microservice Architect and also a Senior Lead for MicroProfile in IBM. During this session, feel free to ask me any questions. You can type the questions in the Q&A window. Afterwards, if you have any questions, feel free to reach out via Twitter. My Twitter handle is Emily FH Jiang. Let's get started. So this talk has two parts. The first part is the basic concept of 12-factor app. The second part is live coding, creating micro services using MicroProfile to demonstrate this 12-factor app. So what is a 12-factor app? 12-factor app is a methodology best practices manifesto published by Heroku. Why do we care about this 12-factor app? Because it defines a clean contract between the application and cloud infrastructure so that they can focus on in their own domain. They don't trap on each other's toes. So they can form a really good ecosystem instead of fighting for the same thing. So this is the TLDR version of 12-factor app. So 12-factor app is the best practices for building software as a service. It defines a clean contract between the application and the underlying operating system. It's suitable for cloud deployment. It minimizes divergence between the development and the production. Also, the 12-factor app can scale up or down without significant impact to tooling and development. The other thing is the 12-factor app is language agnostic. You can choose your favorite language to create a 12-factor app. In my case, is Java. So in this talk, I will focus on how to create a 12-factor Java application. 12-factor app has its name because it has 12 factors from code base, dependencies, config, and etc. to the admin processes. So I will cover this 12-factor later. So you might be wondering how to create a 12-factor app. Is my microservice a 12-factor app? So it could be complicated. However, luckily, MicroProfile and Kubernetes are here to help. If you don't know about MicroProfile is an open source project. It was established 4 years ago by IBM, Red Hat, Tom Tribe, Payara, London Java community, and others. It's completely community driven. Its specs, APIs, TCKs are freely available in the public. There's no reference implementation concept. There's many implementations, but we don't really want to choose which one is reference implementation. So they are all really, really good quality. It has lightweight iterative processes. As you can see, MicroProfile community is very diverse. The contributors from many vendors and Java user groups, individuals, and also there's about dozen independent implementations. So as you can see here, listed a few implementations like Open Liberty, WebSphere Liberty, Quarkus, Wildfly, Payara, Tomee, Halidon, Apache Launcher, Cumulus-E, Hammock, and Prana, and the list is still growing. So later on, I will do a demo creating microservices on Open Liberty and interact with microservice on Quarkus. So this is timeline of MicroProfile. So it's since 2016, as you can see, is each year we do 3 releases. So right now the latest release is MicroProfile 3.3, and right now we are working on the MicroProfile 4.0 release. So in the next 12 slides, I will go through the 12 factors in a little bit more details. So the first one is the code base. So code base, reversion control, and many deploys. So basically, it's one 12-act app, one GitHub repo. So it's easier to manage its release cycle. So the second one is the dependencies. You should explicitly declare and isolate dependencies. You should consider to use a Maven Gradle to specify dependencies. Don't package your dependencies inside your application, and gradually it's like a spider web. Is your dependency become part of your application, and then you started modify the dependency code, and then gradually you cannot swap out the dependencies anymore. So the third one is the config. You should store config in the environment. So when you change the config value, you don't need to repackage your application. You should consider to use Kubernetes config map secret and to store the config value. And then you can use MicroProfile config to inject the config value into your microservice. So it's MicroProfile config is trying to achieve the goal written once, config everywhere. So the config property value specified in the config source, which is external to your microservice, and then you can use the API like config provider or get config, and then get value to look up a specific value, a specific config property. And then you could also consider to use the CDI to inject a particular property into a field, like a my or string properties into the my prop. So in this scenario here, you can specify the password in the Kubernetes secret, and then you can use MicroProfile config to directly look up the config property password and inject into the application. So the next one is backend services. Should treat backend services as attached resources. So basically, this is establish a client-server interaction. So if the Twitter and also the Facebook, for example, implement the same API, and then you can easily swap of Twitter, swap in Facebook, and vice versa. So how can you make this client-server connection? So MicroProfile REST client is here to help. So basically, in this scenario, service A call into service B. So in service A, you can specify service B's interface like get properties and it's a get operation. And then you can create an API here, and then you can only annotate it with the register REST client. And then you can directly do an inject REST client into a field like a default REST client. You can directly call the operation here. And then you might be wondering, how does A know where B lives? So MicroProfile REST client use MicroProfile config. So directly you can configure the service B's endpoint. So here is you use fully qualified class name, this interface, fully qualified this class name, /mpres/URL. You can put the service B's endpoint here. So when default REST client property called, and automatically find out, okay, this is endpoint, I call this endpoint to invoke that operation. The next one is the build release run. So you should strictly separate build and run stages. So basically you do your development, and then you build it, and then you test it, and then you publish it, and then you run it. So you should consider to use a continuous integration pipeline such as Tekton. The next one is the processes. You should execute the app as one or more stateless processes. You should consider to use like a RESTful process such as JAX to create a stateless process. So they share nothing. This process has its own database and etc. And then it can scale up or down without any losing any information. So this process is like a cattle, not a pet, because they are replaceable. Where pet is never replaceable. So the next one is the port binding. Export service via port binding. So do not hard code your port, because when you deploy your microservice in the cloud, the port normally change. So you should, if you need to know the port, you should inject the port instead of hard code the port. The next one is the concurrency. So basically, you should consider to use auto scaling to directly scale out your process, or scale up or down based on the load. So the next one is the disposability. It should maximize robustness with fast startup and graceful shutdown. So your process should be start up fast, gracefully shut down. Should consider to use very lightweight runtime, such as Open Liberty or Quarkus. And also you design your processes should be start up fast, shut down gracefully as well. And the other thing is that you should consider your process is independent. It should be able to behave no matter what. Even if the underlying backend is not working, the process should be still behave. So you can use MicroProfile fault tolerance to make it resilient. So MicroProfile Config offers many capabilities such as retry, circuit breaker, bulkhead, timeout, fallback. Is purely annotation based. So I will demonstrate later in the demo. So the next one is dev product parity. You should keep the different stages as simple and similar as possible in terms of team and code and environment. You should consider to use Helm operators to manage the deployment. The next one is logs. Treat logs as event streams, and your application should system out directly. And also you should directly connect ELK to do a log analysis. So the final one is the admin processes. You should run admin tasks as one-off processes. So you should consider to use Kubernetes jobs or kubectl exec. In this case, once this one-off process finished, and this Kubernetes jobs will terminate itself. It will not waste resources. You just pay when you need it. So do not write these one-off processes inside your application. And in this case, your application's size will increase and carry the burden all the time, and you only use it very briefly. And once in a blue moon, so it's not a good resource usage. So this is a quick run through this 12-factor. So code base, you should consider to use GitHub. Dependencies, Maven, Gradle. Config, backing config, you should use the MicroProfile config. Backing service, use MicroProfile REST client. And processes, should use JAX-RS to create stateless processes. And port binding, use MicroProfile config, directly inject the port whenever you need. Disposability, you should use a lightweight runtime, and also use MicroProfile fault tolerance to create resilient microservices. And then in the build, release, run, dev product parity, logs, this is best practices. Concurrency and admin processes, you can use Kubernetes. So that's a quick, quick run through of the part one, and then we are ready to create 12-factor app. So first, I need to create a microservice. So I can use the MicroProfile starter to directly create microservice. So in this demo, I created 2 microservices. So service A running on Liberty, directly call into service B running on Quarkus. And then I demonstrate a factor app. Let's start create this microservice. So this is the starter. So first, let me create a service A. So on the MicroProfile latest version 3.3. So as you can see, many runtime for you to choose from. I choose Open Liberty. So here I wanted to do a client server interaction, so I use the REST client. So here, let me start it. Let's have a look at the code. So let me the previous and through. So it creates some code, and also the important thing is so here is runs on Liberty, and then I use POM XML to specify the dependency. Here I use MicroProfile 3.3. And this is service A I created. And also I use the same way to create a service B. In order to save time, I already created. So service B, so you can see here, it uses MicroProfile 3.2. So it runs on Quarkus. So the most important thing is the service B, it has an endpoint. It has operation do something, take a parameter, and also the get operation. So I want to invoke this service B. So in service A, as you see, how can we make the client server interaction? So in service A, so as I mentioned earlier, so is I created the interface, is implemented by service B, which is do something, take a pass parameter, and then get operation. Only need to annotate a register client. And also in the service A now, I can inject an instance of this service into a field service, and then I can directly call it. So now, let's see. Service B already started, is running on the port 880. So here, the port 880, and let's start service A. So service A is running on Liberty. I can start in the dev mode. So Liberty dev mode, which means I can start my microservice, and also I can do the development. I can make put in more business logic. And while I was coding, I can see the changes straight away without doing anything else. So this is, if something goes wrong, you will see the error straight away. So this is service A has started. So it's running on the port 9080. You can see here, localhost port 8080. Make it bigger. Let's go to the website. Let's see. I already started this. So this one, as you can see from bottom of it, this is equal to the my client server interaction here. So I click on it, nothing happened. So it's not working. Why is it not working? Let's see. So the interface is okay and injection is okay, but did it go to the service B backend? No, it went to a different service B. So here, the service B Quarkus live on 8080. So I just make that change, and then I go back. See, now it's calling to Quarkus's service. So it's now, if I change the Quarkus here, if I say J4K, so the Quarkus has started in the demo mode as well. So if I make that change, and then you can see it pick it up straight away. So now let me demonstrate how to store config in the externally. So now consider here, I will say we are live at conference, and then I can configure the conference. I can say, as today I will say the J4K, but in some other time maybe I go to another conference. So I don't want to hard code the conference. So I can say I want to inject the conference. So I can see the property, and then I want to specify the conference, the string conf. So here, import here. Now is I save it. Now I need to specify the conference. MicroProfile config provide MicroProfile-config properties for you to store the default the value. In here, I can say J4K. Save this one. Now let's go back here. See, we are live at J4K. I haven't done anything to do with the server and automatically pick up my chain. So I demonstrate the third factor. I also demonstrate the binding services, the binding services. And the next thing I want to demonstrate how to create a resilient microservices. Let's demonstrate this microservice here. So as you can see here, sometimes it's really slow and sometimes it doesn't work. So let's see how can I fix that problem. So that doesn't work is because in service B, on purpose to make some sleep and also throw some exception. So this is a real case scenario. Like sometimes you cannot control your backend. Your backend maybe got a bug, but you cannot doesn't owned by you. So you have to look after yourself. You have to change yourself to cope with the backend behavior. So this is what fault tolerance does. So okay, so fault tolerance, it has the capability like, okay, if something not working, the instinct tell me to retry it. So you can retry it. And sometimes, see, you fix that problem, but you haven't fixed the slowness problem. So considering some time critical operation, you want your microservice behave all the time and come back in a time of like a good timing. So you can say, okay, I only have 100 milliseconds to spare. If you don't come back within 100 milliseconds, I want you to time out. So you can say, okay, at most, it will time out if it's over 100 milliseconds. When you use the timeout, the best practice always to use synchronized programming. So here you can use fault tolerance, make this operation running by a different thread. So so in this case, the return should be the completion stage. So it's in here, and then it's completion stage, and then can return the completable future dot. So it's in here. So it's let's see whether it fixes this slowness problem. Now you can see it's always come back in a good timing, is because if it's longer than 100 milliseconds, it will time out and then retry automatically kick in to retry the operation. So it's so you get in this case it's demonstrate without changing the backend, you fix the problem yourself. So the other best practice is always provide kind of the fallback operation. So basically, if something wrong, you should provide a contingency plan, which is a fallback. You can say, okay, if something goes wrong, and please call my fallback method fallback. In this case, I can create this method fallback with the exactly same signature as the parent operation. So fallback. In a fallback, you can have many kind of different logic. You could choose to call a different service, or you just return a cache or something. Or in here, I just return a pre-kind string. Okay, so that's kind of demonstrate how to use MicroProfile Config to externalize your configuration, how to use fault tolerance to create a resilient microservices. So the next thing is this is finished. If you are happy with it, this is finished development, and now it's kind of you should containerize it and go to production. So the thing is for containerization. So basically, you create a Docker image, and then you can push it to the Kubernetes. So let me show you how to create a Docker image. So it's in the service B, and obviously you can do a quick build. Maven compile Quarkus build, and then you can do create a Docker image. And similarly in service A, and then you can do a Maven verify to do a build. And the next thing, you create the Docker image. And then so I copy the Docker file here, and then I create a Docker image. So let me show you the Docker file. So Open Liberty kernel, and then you copy the WAR file and directly run config.sh. And then afterwards, let's prepare to create the deployment. So you can copy the deployment. Basically prepare to copy the deployment. So let me go through the deployment. So after you have create a Docker image, and then the next thing is push the Docker image to Kubernetes. So in order to deploy deploy this to microservice, you need to create a deployment YAML file. So for each microservice, like you need to deployment. So in service A, you have a deployment, and then it's in the deployment you specify your image. So basically, this is the Docker image we created, and then the container port, and then you can specify the environment. So this is very important. So this environment, we specified in the here com example Liberty client server and then wire to the backend. And obviously, with the deploy to Kubernetes, the host change, the port might change. So and then I have MicroProfile config provide a way to be able to override the config value. So I use the environment variable, which is has a higher ordinal than this MicroProfile config properties. So I can say com example Liberty client server MP REST URL, but the dot and the slash all convert to be underscore. That's because the environment variable name is only allowed to have a character or numerical underscores. And then I can specify where does the service B lives. And again, like similarly, the conference, I put the J4K inside here. And then in the YAML file, I overwrite with virtual J4K 2020. So in this case, I can freely change this value without needing touching any the Docker image whatsoever. It's so so, and then that's a deployment for microservice A. Similarly, deployment for microservice B, I can just specify the Docker image, so which is this Quarkus service B. And then it's a service. So for service A, I create the type in node port, and then the node port number is 380. So this is the external traffic policies cluster. And for the upper B is the inside the cluster. So I give it type cluster IP is only visible inside the cluster. So its name is factor app B service. So which is why here the value is factor app B service. So the port is 880. So here is the port is 880 target port. So that's why it's kind of I can configure here and it still works. So let's see like service A is all up. So in order, so I can apply the YAML file. So because I already started yeah, yesterday, so it's still running. So as you can see here, if I do get services, you can see the factor app A live in the port 380. So let's go in here, localhost. See, this is Live virtual J4K 2020. So one more thing I want to demonstrate is if I say virtual 22 AK, so if I say September, so I changed that. And then I can easily do a kube control apply. So it give it change. If I do a get port, you can see some port has been destroyed and restart again. I don't need to repackage my application. So it's someone is been terminating and taking down. And while it's doing that, so again, you can see the two instances. Why is the two instances? Because in the deployment, I see the replica is 2. You can do a further improvement and to use the auto scaling to scale depending on the load. So let's see whether it's yeah, it's up running. Let's go back here. See, you can see September automatically picked up. So that's demonstrate how powerful it is when you externalize your configuration. So that's kind of briefly tell you about the like a demonstrate the 12-factor app. So it's just go back to here. So here is use MicroProfile Kubernetes, build a microservice, demonstrate a 12-factor app. So make best use each like microservice and infrastructure. So they form a really good ecosystem. So and then the recap code base, GitHub, dependency, Maven Gradle, config backend service processes, port binding, disposability, can use MicroProfile, build a release run, dev prod parity logs, best practices, concurrency, admin processes, Kubernetes. So this is the kind of the takeaway references. So check out microprofile.io. OpenLiberty.io has many guides for you to learn about like microprofile, and also the demo coding is all checked into these 3 GitHub repo. So it's one code base per microservice. So the first factor, and then the POM XML like demonstrated dependencies. So you can easily like uh, uh, you can easily follow this instruction and try out this 12-factor app. So that's concluded this talk. If you have any questions, feel free to ask. So that's the end. Thank you for watching. Bye.